Here are the solutions to the practice test. The first one was to compute the net force and the acceleration of a 240 kilogram object subjected to an upwards force of 6,000 newtons. So we have an upwards force of 6,000 newtons and a downward force of 2,400 newtons by using the force of gravity. This means the sum of forces would be the up force plus the down force, or the up force can be called the tension. And if we choose down negative and up positive, we would get 6,000 newtons minus 2,400. We have 3,600 newtons up. Sum of forces is MA, so we can rearrange that to this equation. I dropped the sigma here because I know how much you hate it. We put in our numbers. We got our answer, 15 meters per second squared. I recommend the stairs rather than taking this elevator because this is clearly Willy Wonka's elevator and someone has pressed the up and out button. 15 meters per second squared, 2 seconds here at highway speed. You're going to be breaking the sound barrier in 20 seconds. That's a little hefty. An object of unknown mass accelerates to the left at 5 meters per second squared. What is the mass of the object if it's subjected to a 200 Newton force to the left? Okay, the opening statement immediately tells us we have an observed behavior. That is related to the total force. All we need to know is the mass, and we can get that total unbalanced force. Wait a minute, it's stated right there. So ignoring my bad grammar, I just told you what F net is over here. It's 200 newtons. Now we have F, M, and A, and you have both F and A now, so you can easily solve for the mass of this object. Now, having the mass and being told that the total force is 200 newtons, it has to be, because that's what I told you in the question. There's your unbalanced force, your net force. And we have friction, though. And the friction is going to be around 480 newtons by the time you're done here. Okay? That's a little bit of rounding. So somehow, the 480 newtons drag, when we're done, we have to have 200 newtons extra. So this means if we need a total of 200 newtons and we know there's 480 newtons taking away from the answer, we must have 680 newtons push on this object. 480 newtons comes off due to friction, leaving 200 newtons spare. A 79 kilogram object on a surface, what force is necessary to keep it moving at constant speed? All that's asking is what is the minimum force to overcome friction. So we can calculate the frictional force using our standard formula. Along here, we get 209 newtons basically. The object starts at highway speed and is coasting, so the only force on it is this friction. And since the sum of forces is MA, we can arrange this 209 newtons over mass gives us that this object is slowing down at this rate. Now think about that. When we want to decide how long is it going to take it to stop. You start at 30 meters a second and you're losing this speed every single second. So in 10 seconds, it's going to slow down by 26 meters a second. So if in 10 seconds it goes from 30 all the way down to 4, like we're looking at 12 seconds tops. And so your math should agree with you. If you flipped it by mistake, you would have got 0.01 seconds. If you'd multiplied, you would have got over a minute. But a casual examination of these two numbers, you're only in the 10 to 12 second ballpark and you've come to a halt. Now, a Honda Odyssey from earlier, we discovered it could reach highway speed in 7 seconds. So stopping in 11 is a pretty good stop. That's not a gentle, this is like grandma loses her dentures, you spill your coffee. But it's doable. It's not going to kill you. Now, is it going to take more force or less force to lift it? Well, this coefficient says it's going to take 20% of the object's weight will be felt in sliding it. So this object is like 80 kilograms. So you're only going to be pushing like 25, 30 kilograms. You just take this mass, multiply it by 0.27, and it would tell you exactly how many kilograms you need to push. It's much easier to slide it than lift it. This one, an object of 210 kilograms, is accelerating like this. There is an applied force. It doesn't say net force, an applied force onto the object. Okay, so we have this, which is giving us our net force. So since I've told you its behavior and I've given you your mass, we can go for the net force right away. The net force on this thing is 1,300 newtons. Now there's an applied force of 2,367 newtons. This is that poor schmuck. Every one of my diagrams, this poor little stick man gets stuck pushing. It's like, and he's still scrawny. Come on, stick man, eat some more. Stick man, little skinny stick man. But I already told you the total force on the object is only 1,300. So we have a total force of 1,300, but this poor sap is pushing with 2,300. Where did like over 1,000 newtons go? That was the friction. So the friction is 1,044 newtons. Over here, see? Now that we know the friction force, we can rearrange. The force of friction is mu Fn. So if we solve for mu, it's friction force over normal force. There's our friction force. And our force of gravity is 210 times 9.8 mg. And we get a mu of 0.57. Fairly rough surface. I'm going to pause here before I run out of time, and we'll come back for the next set.